All right, so the recording has started, just so you know. This is the daily check. First one. We want to select the numbers that are irrational. What does it mean for it to be irrational? No. You can't write it as a fraction. Tell me something else about irrational. Emma. It will not terminate as a decimal. What else will it not do as a decimal, Autumn? It doesn't repeat. Okay, our first one is the square root of 2. If we put the square root of 2 into our calculator, what do we find about the square root of 2? It's a non-terminating what? Decimal. And anytime our square roots come out to be a decimal, we categorize it as, it becomes irrational. The next one, there was questions brought up. It's written as a fraction, yes. But there's something we need to work in the fraction. What do we need to work?
Square root.
Okay, so on the top I have the 10. On the bottom, what is the square root of 100? 10. And 10 over 10 is 1. 1 is rational. What else is 1?
A whole number.
Whole, integer, natural, real. It's all of them that we've been studying. Square root of 7. Why, Idris, do you say it is irrational?
Because if you put it in your calculator, it comes out as a decimal.
Exactly. That is enough reason. You put it in the calculator, it becomes a decimal. So that's automatically irrational. The next one, Kara, is the fourth one in my list going to be rational or irrational?
Rational.
Why? Good. Repeating decimals are automatically rational. Your calculator can convert it to a decimal. To a fraction. The bottom one, we have the square root of 8 being divided by the square root of 2.
Oh, irrational. Well,
It's rational.
Ooh, I have one saying irrational. Okay, we saying irrational. We talked about fractions and square roots when we were doing the previous unit. If both of them have a square root symbol, the whole fraction is under the square root symbol, right? Okay, well, I'm going to write it like that. I have 8 over 2, and they are both under the square root symbol. What's 8 over 2?
4.
What is the square root of 4?
2.
This is rational. Your calculator, had you relied on it and just stuck the whole thing in, would have also calculated this out as 2.
That's what I got.
Very good. Okay, the next parts. We had some word problems with our scientific notation in the last unit. Some of us were a little thrown off by them, but you got to remember they're solved just like any other word problem. During its productive years, an apple tree can produce a certain number of apples. Okay? That's the number it's given you. We're being asked how many apples can be harvested from an orchard of 600 trees. If one tree produces a certain number of apples, how would I find for 600 trees? I don't want to add anything 600 times.
oh.
Okay, let me put numbers into this. I have an apple tree that can produce 10 apples. How many can 5 of my apple trees produce? One of my apple trees produces 10 apples. Now, how'd you get that? 10 times 5. Now, I have an apple tree that produces a large number of apples, And I want to know for 600 of these trees.
60.
Yeah, multiply the numbers together. The apple tree produces the scientific notation in apples.
Are you trying to find how many apples are on 600 trees?
Yes.
So why could you not just do 600 divided by, wait,
Never mind.
Because the number given is for one tree. And I want to know for 600 trees. So this becomes multiplying. Now, if our calculator has to be in scientific notation, what is the calculator sequence that we need to keep in mind?
Second DRG arrow.
Second DRG. Good. That is something to remember since it specifically says your answer needs to be in scientific notation. And a hand when you got an answer. I got 6. Dola, what'd you get for your answer?
1.05 to 10 to 7.
Very good. That is the correct number of apples for the 600 trees. Very good. The next 2 daily checks, the boxes in the middle, is bringing in equations. Equations are studied in 7th grade. I know for a fact my classes were phenomenal with equations. Okay? You'll remember it once we start doing it. It's the thing where all of a sudden you were drawing your lines and starting to do stuff on each side. We were super strong in this. And equations are basically going to be the majority of what we cover from now until Christmas. All right? It's going to be very methodical. I want you to be very organized, very neat in how we show this work. If you practice a constant process, it becomes very, very simple. Okay? So we're going to do this one on the left. And the first thing, we need to view it as 2 sides of a problem. And if I look at the left side of the equal sign, I'm going to go ahead and draw my lines. If I look at the left side of the equation, what do you notice? It is a subtraction problem. What else do you notice?
You notice the variable.
Oh, you just used a plural on variable. Because there's how many variables over there? 2. So are they the same variable? Which means we probably need to start with the C, L, and a T.
Combine
Combine like terms.
Combine like terms. Okay. We want to combine like terms. CLT, combine like terms. When we combine like terms, let's kind of relate this back to that exponents unit. When we're adding and subtracting and combining like terms, we do not change the variable. We focus on the coefficient. The negative 9.76 minus a negative 12.81. What do you get when you combine that? In your calculator, just put this in your calculator. Notice what's highlighted. Not the D's, but the numbers and the signs. Put that in your calculator to combine it. And I believe I heard 3.05. Okay. So my equation is now 3.05D equals 8.54. I know this looks familiar. Noah? What are we going to do? we need to divide off the number next to the variable. And whatever we do to one side of the problem, we do to the other side of the problem. That's going to leave us with D is equal, Emma?
2.8.
To 2.8. Now, if you notice something in the directions, it says solve each equation, but then it says check your answer. Most of the equations we do, we should never get wrong if we take the time to check our work. And checking your work involves you taking what you think the answer is and plugging it back into the problem and seeing if it works to give us a true statement. So we are going to check this. And I'm going to replace the D with 2.8. So I have negative 9.76 times 2.8 minus negative 12.81 times 2.8. And I need it to equal 8.54. So very carefully in your calculator, you are going to put all of this very carefully. So negative 9.76 times 2.8 minus negative 12.81 times 2.8. What do you get in your calculator? Okay, the left side becomes 8.54. That's equal to 8.54. So you've just checked your answer to be correct. If you got a statement that was not equal to each other, you have an error in your problem. Okay? And you always want to check your original problem. We good? All right, I'm going to slide this over a little bit so we got some work room. On the left side of this equation, what do we notice needs to be done? I got my lines.
You gotta combine like terms.
Okay, I've got some combining of like terms that has to occur. And when we combine the 0.8n and the 0.6n,
0.14.
no,
1.
1.4n. Watch the placement of your decimals. So I have 1.4n equals 42. What's our next step? Divide by 1.4. And n ends up being, well, we think it ends up being equal to 30. And we're going to check this by plugging 30 back in. So 0.8 times 30 plus 0.6 times 30. We want it to equal to 42. Reagan, does it equal 42? She says it equals 42. So we've proven our answer to be correct. This is going to be really important, especially the more negatives we start throwing into these problems. We good? Is it starting to like refresh a little bit from last year? Okay. I hope so, because we spent a lot of time and we were really, really good at this. Our next ones. I know we see fractions, we panic, but what's our new favorite fabulous tool?
Calculator.
Yes, this handy dandy scientific calculator that works fractions for us. So on this problem right here on the left, what do we want to do?
We're gonna those fractions
I'm going to combine like terms, but I don't have to change anything if I use my calculator. I can do 4/5 minus 1/4. That's okay. Can I change it to decimals and do it decimals? Yes. I am good with either. It is totally up to you. Emma, what do you have when you combined your like terms?
Well, I got the fraction.
All right, what's their fraction?
11/20.
Okay. So she has 11/20x equals 11. If you have a decimal, what's your decimal? All right, 0.55. I don't care which method you use because your next step is all going to be doing what?
Lot.
No matter which step you just did, you're going to divide.
How do you divide?
You could use decimal, you can flip and multiply, or you can put it in your calculator. Because ultimately, you're dividing by the number next to your fraction. So your calculator, just put it in your calculator correctly. 11 divide 11 ABC 20. And you get 20. You can do decimals too. Yeah, you've got more options this year with this calculator, okay? Just for time's sake, I'm not going to check the answer on this one, but 20 is correct. How would you check the answer?
Plug it in.
Plug it back in. Correct. How about this next one? Where you see a 1. There's an invisible 1 there. That's the reason that chart's going to stay up on the side of the board all year long until state tests come. There are invisible things in math. That 1 coefficient is one of those things. And then we're going to combine these. Who can tell me my new equation after combining the like terms? Emma.
1.15x equals 3.45.
Good. 1.15x equals 3.45. And our step to go do next is division by the 1.15. And how would I write my solution? I'm a stickler for this. Noah?
X equals 3.
Good. X equals 3. I'm a stickler for the variable equaling its number. Okay? It'll help you when we, swap brains to inequalities. And if we don't have the inequality symbol, my answer is wrong. Okay? So let's just be in that process. Okay. So we've kind of cleared off some cobwebs, reviewed over some equations. I think we're remembering this a little bit. And our next slide is this. It's on your notes, but it's very faded. It is a poster in our room now. Okay? We were going to reference this probably the rest of the semester. And it's on a cell phone for a reason. Okay? Because it says, don't call me after midnight. Don't call me. No.
I got that poster.
So don't call me after midnight. If you notice, it's color-coded. If you want to highlight and color yours on your notes, you are 100% welcome to. Okay? But in the don't, the D is standing for the distributive property. We have to make sure the distributive property gets done. The call stands for combine like terms. And we just combined a bunch of like terms. The newest thing that we're going to be having is the me. And it's the moving the variable. That is going to be the absolute newest step for most of us. Okay? And then the after midnight is getting into the solving the basic equations like we were doing last year. We add or subtract, then we multiply or divide. Okay? Like I said, I'm keeping this poster up. We're going to reference it a good bit this semester. But don't call me after midnight is our way to process how to solve these equations. Because they're going to become very multi-step very quick.
I'll call you after midnight.
You'll fail. Sorry. Okay, ready for your first problem? I love his enthusiasm. No, we're not ready for this. Okay. First step, number 1, you need to write it down exactly as you see it. There's our problem. 5p minus 3 equals p plus 2p minus 5. Do we notice something different from what we've been doing? Noah, what do you notice is different?
I noticed that instead of
Emma?
I can't say it.
Yeah, there's variables on both sides of this. That's where the move variable is going to come in on this. Okay? So first thing, we're going to view this as 2 separate expressions. Okay? And I want us to look on the left side first. And we'll just cover the right side up for now. I'm looking at the left side of my equation. I'm checking the don't call part. On the left side, is there the distributive property? No. Are there any like terms to combine? No. So the left side of the problem is fine, right? There's no distribute, there's no combine. Well, now I want to look on this side. I'm going to look at the right side by itself. Any distribute? No. Any combining? Yes. That's what we need to do first. Thank you. So we are going to combine like terms. P plus 2p.
3p.
3p minus 5 is on the right now. Now we need to reveal the left side. Nothing changed on the left, did it?
No.
Bring it straight down to next to it.
Miss Longwood, 5 and 3 not be like them.
Unfortunately, they're on opposite sides of the equal sign. One's on the left and one's on the right. So they are not like terms. They're on opposite sides of the fence. Okay? So the don't call is the first thing we need to be paying attention to. Now we're going to look at the move the variable. I have tend to notice we like the variable on the left side of the problem. We're going to keep the variable on the left side. So we're going to get rid of the right side of it. We're going to get rid of the 3p. How are you going to get rid of 3p's? How are you going to subtract them? We literally getting rid of the whole thing. So 3p, we're just going to minus the 3p out of it. And in doing so, we have to remember something very important about equations. If I take something off the right, I got to take it off the left. And if you notice how everything needs to be lined up, this is where I say be very meticulous, be very detail-oriented here. Okay? It'll only help you. All right. Now I'm going to simplify some stuff down. On the left, I have 5p minus 3p. I got 2p. And I got the minus 3. And I got the equal sign. What's left on the right side of my problem? The negative 5. Whoop. Now it's back to everything we studied last year. Does it look familiar?
Yes.
Yes, I hope it does. So we draw our lines. And what is it that we are going to want to get rid of first? Get rid of that minus 3 by doing what? It's already minusing, so we need to, yeah. We want to do inverses, so if it says minus 3, we're going to add 3. Okay, all that's left now is 2p equals is negative 2. Well, what do we do now? Divide both sides by 2. And our work is telling us that p is equal to negative 1. Well, unfortunately, I hate to be the bearer of this news, but some of these problems are going to get a lot more steps than this. It is. Okay? You will get into some problems that could take you up to half a page to do. You'll do fine with them. Just follow the details. But I want us to check. We ran into this question and last class, one student said negative 1, one said 1. I said, okay, we're checking our work. Because we will run into that problem. You'll be working with your group and all 3 of you could have different answers. Well, all 3 of you need to check your work then. So we're going to come back to our original problem. And every p will be replaced with a negative 1. So I have 5 times negative 1 minus 3. And that's going to equal negative 1 plus 2 times negative 1 minus 5. I replaced them.
You have to do a side first.
I do have to do each side separately. So I'm going to do the left side in the calculator and get an answer. So 5 times negative 1 minus 3
Negative 8.
gets you negative 8. All right, now I'm going to do the right side of the equation. Negative 1 plus 2 times negative 1 minus 5.
Negative 8.
You get negative 8. The 2 sides match. You've just checked your answer. And if you and your group have differing answers, this will prove that somebody's right, somebody's wrong, and you can go back and analyze your work. Okay?
Why do you write your check marks backwards?
Well, maybe yours are backwards.
Are you left-handed?
I'm left-handed.
That's why.
I'm left-handed. I got 2 though.
Like senior here writes his check mark backwards. He writes everything backwards. He's weird. Oh,
Wait, this one.
Uh-huh.
I love him,
Shh.
but
Okay.
How do you know negative 8 is right?
Because if I worked all my steps out, 5 times negative 1 would be negative 5. Negative 5 minus 3 is negative 8. If I do the other side, multiply first, I would have negative 1 plus negative 2 minus 5. I would add the left, so negative 3 minus 5 gives me negative 8. Your calculator does follow order of operations. What you're checking is, does your value of your variable prove that the equation is true, that the left side equals the right side? If you got 2 different answers, like 2 different numbers on each side, then your answer is wrong, and we need to go back and look at our work. Okay? Here is equation number 2. All right, so first major step, write it down.
I'll write it down.
Well, if you don't write it down, you're gonna have the wrong answer.
What if I like guess the right answer?
Unfortunately, what we're gonna run into in a few days, we're gonna run into this next week. You will have equations that you seriously cannot guess the answer to because you will run into equations that don't have a solution. Or equations that have infinite solutions. So like all numbers will work. It gets to be weird. Yes, ma'am. Okay. John,
How do you solve problems with infinite answers?
we're going to talk about that next week. We'll talk about it next week. All right. I am separating my equation at the equal sign because the don't call has to look at the left and the right separately. Okay? So I look at the left side. Is there distributive property? Combine like terms? No. Now I jump to the right side. Is there distribute?
No.
Any combining?
No.
No. So now I go to the me. Do I need to move a variable? Yes. There's a variable on the left and there's a variable on the right. Let's get rid of the one on the right.
So you do plus two, plus
Add it, plus it. It says a negative 2n, so we're going to use its opposite of plus 2n. Whatever I do to the right.
to the left.
There you go.
Wait, what I thought was whatever you did to the left.
I have just noticed that it seems to do better if we do the same thing constantly and move it, getting rid of the right variable, that puts your variable always on the left. Will it always go like that? It just depends on the person, to be honest. Okay. On the left side, I want to start with my variables because I want to flip so my variable really is all the way on the left. What is 2n plus 2n? 4n. What is still on that problem though?
Negative 11.
Negative 11. And that's going to equal how much on the right?
Wait. Stop.
Stopping.
Draw. Okay.
Well, how did you put the 4n plus 5?
I like my variables all the way on the left. Some people it doesn't matter. But then some people that they like if everything looks the same constantly, they're just more successful.
Okay.
Okay. On the right side of the problem, if you have negative 11 plus 4n, Noah, go with it. You'll still get the right answer as long as you do everything right. What do I have on the right side of my problem now?
5.
I have a 5.
Yeah.
Now we're back to our 7th grade math skill. Woo!
Draw the line.
I draw my lines. Okay, I drew my lines.
And you have to, then you,
Theron?
Add 11. You cut the 11
Okay,
off.
so get rid of the minus 11.
You on the left, you on the right.
You are correct.
and then it's
Emma?
4n equals 16.
Very good.
Then you divide.
All right, what's my next step here, Noah?
You divide by 4.
Divide both sides by 4.
Yep.
And n, Emma?
n equals 4.
N equals 4. Well, let's just say you and Noah got opposite answers.
No, I got positive 4. You get negative 4. Let's keep it that way.
I mean, it could be anything because, I mean, one point Noah brought up, why did we flip the problem? Well, some people flip the problem and mess their whole thing up. So let's check the work, and see who's right. Which equation do I want to use when I go to check it?
The original.
The very original problem. So I have negative 11 plus 2 times 4. And then on the other side, I have negative 2 times 4 plus 5. We're going to look at the left side And then you're going to look at the right side. Idris, you got the left side?
Yeah. It's
What do you have, sir?
It's -3.
It is -3. And the right side, Noah?
-3 also.
-3 also. So 4 is the correct answer.
Yep.
Good.
We did it.
We did it. Yay. Question 3. You need to write it down.
Hey, I learned what 3 is in space. What's long? Somebody broke your calculator screen. Why did they do that?
I don't know. Okay, so we write our problem down. 4v minus 2v equals 5v minus 4v plus 6.
I know something.
Just like the last problems. Let's view two sides. What are we checking for on each side? Bella. What do we need to look for on the left? Okay. Do you have any?
Yeah.
Okay. What do I want to do with these like terms? Okay. If you combine them, what is 4v minus 2v? It is 2v. And then on the other side, what do I want to be looking for? Parker. What's on the right side that we need to be worried about, that we need to take care of? No, not yet. Remember, our cell phone poster, we have to look at our problem. We need to focus on the don't call, the distribute, and the combine like terms. Is there anything that has to happen on the right side of the problem? You got to combine like terms. If we combine those like terms, what do we have now, Emma? 1v plus 6.
Wait.
Hold up a second. Go. 2 questions. First question.
That it doesn't make sense.
We're not finished yet, though.
Do you subtract like needing 1v like minus 1v or do you
Yes.
2v minus 2v?
We want to get rid of the one on the right. So if we get rid of the one on the right, it's a 1v, so I'm going to minus 1v from both sides of my equation. When I do that, on the left, 2v minus 1v is just a v. You got 1v, and it's equal to,
We can solve that.
that's done. Other than checking your answer. I want you to check your answer, and I want to know what you got on both sides of the equation when you plugged in your answer. I'm going to pause our video just a second and give people a chance to do this. Okay, so plugging 6 back into the original equation, what did you get on the left, Juju? What did you get on the right, Autumn? So v equals 6 is? It is definitely correct. It is the right answer. Woo! Okay. We did not get through a ton of these, okay? But we're going to pick up with it tomorrow. The days are going to kind of blend together, but I want you to stop. I want you to go to the homework part In here. Oh, shush. Wait until you complain. Hold the complaints. Just wait until we complain. Okay? All right, so listen up here on the homework part, because this is for all my classes, so everybody knows what's going on. Okay, when you go to the homework, it's going to say variables on both sides homework. Do you see where I'm at?
Yes, ma'am.
Okay, I want you to, those are your problems, right? I want you to look at the back of that sheet of paper, and it's a bunch of boxes. That's where you check your answers.
Oh.
Okay? Now, you're only doing the odd numbers. So it's 5 questions. 1, 3, 5, 7, 9.
Oh, thank you, Miss Ma'am.
Okay? But instead of having to go like this with your paper, that's really annoying, right? Because you're trying to check your work. Here's a little trick. If I do it like this, and then I fold it long ways, it's like a little smart stuff. It happens every now and then. Then I answer question number 1. I can just fold it over, and there's my number 1 check right here. So instead of flipping your packet, all you have to do is just kind of fold your sheet in half. Make sense? Okay? It might save some of us a headache. But I don't want you practicing 10 questions in case you do 10 questions wrong. Okay? I want you to practice the very same steps we've been doing, the whole don't call me after midnight. 5 questions.
How did you think of that?
What, the folding it?
No, don't call me.
I stole it off of something else that I saw. So it is not mine. I just
What about copyright?
have their picture hanging in my classroom, and they were phenomenal coming up with the idea. 5 questions tomorrow, correct?
Yeah,
All right, good deal.